So now, the purpose of this circuit, we just have the 555 wired as an inverter. Output is low right now. It's pretty close to ground right there. It does a pretty good job connecting to ground. It does not do a good job connecting to the positive supply. Usually, it's about a volt, maybe a volt and a half away. We have a pull-up resistor, though, that is helping. And the transistor is probably even helping a little bit right there. But in any case, we put the pull-up resistor back. So the pull-up resistor can get us to 5 volts, basically, but it cannot power a load. So instead, we got a PNP bipolar junction transistor right there. When I get a low output signal to the PNP bipolar junction transistor, that turns it on. And this load would not get anywhere near 5 volts from the output of the 555, but with the transistor we do get pretty close to 5 volts across the load right there. So if you need, pretty close to the full voltage, this is one way to go. So now we have my schematic diagram. I got a 555 timer there. Using that, I want to put 5 volts as close as I can across a red LED that's headed to ground. So the output of the 555 timer does not do a good job of producing a high output. You lose some voltage. So we can just use a PNP bipolar junction transistor. When it's on, we're going to get close to 5 volts across the load. Of course, we have to connect the output of the 555 to ground to get it on right there. Now, what's this pull-up resistor for? When the output is high, as I said before, it doesn't get to 5 volts very good. So the pull-up resistor will help do that. That helps make sure that the PNP bipolar junction transistor stays off, which may or may not be a problem. But the pull-up resistor cannot really provide power. And always remember, when wired as an inverter, we get the opposite output of what signal we give.